Okay, you can't get confused in the textbook. So pay close attention and hope you are active. You got pencil and paper and you're writing down, eh? Right, let's look at this diagram. You got a shaft over here. It's a shaft because you can see its diameter. Okay, with different diameters, 20, 30, 25. And you got loads that are applied intermittently along the shaft here. Okay, and giving the diameters of the different areas. Okay, I just want to just see something here. All right, so we spoke about equilibrium. All right, okay. Now, this question will ask you now. Okay, let's just look at the tools here quickly. There's two things here. One is now they will always ask you what is a change in length. This is the expansion or compression or contraction that we were talking about earlier on. Okay, that's the main thing that you want to calculate. Okay, so you know for sure that it will not touch an adjacent component in your engine or wherever. Okay, so the total change in length of the member is equal to the algebraic sum of the changes at different parts of the member. Okay, so very easy, eh? So all they're telling you here now is the total change of member AE is equal to the change of member AB, BC, CD, and DE. So you got to add up each segment. Very easy stuff, eh? Right. So that's all they are telling you. So the rules are very similar to beams. Wherever you see a force, you put a letter. I like to draw it inside, not like the way they do it. So you also draw a rectangle or whatever, and inside you put in your lettering. Right. Wherever there is a force, you always put a letter over there. Wherever the change in cross section, you always put a letter. I explained to you guys very, very nicely. And I'm a bit disappointed with the results in beams. A bit disappointed. Some of you guys done very well, but some of you guys don't have a clue. I wonder whether you even attend class. Okay, but it is your prerogative. I cannot force you, eh? I cannot. You don't want to, you can't force you to drink, eh? So you need to plan and manage yourself well, eh? Right, wherever there's a change in cross section, you also need to put a letter inside, as they've done here. You can see B, A, B, there's a change of cross section here, where I'm flashing my cursor. So it must be a letter. Some of these questions don't give you a lettering. So you have to put them yourself. At C, there is a force of 30. So that's why now, sorry, yeah, it is a force of 30. So that's why it's called C. All right. You see now why they give you the distances, why they give you the dimensions or the diameters. Right. So this question basically wants you now to determine what is the total change in length. Okay. So the total change in length now, they will give you the Young's modulus. Okay. The failure of mode can be tension or compression. So that's why you work with Young's modulus. Okay. Tell you determine the magnitude of force P required for equilibrium. Even if they don't ask you, the students, you must calculate P. Okay, that's the equilibrium thing we spoke about, summation of forces, eh? All right, you can see here this force P here, you don't know it. So it's very easy to calculate that. All right, so force P now, you can see now, there is the summation of forces along the X direction, must always be equal to 0. Okay, so it's got plus 20 minus 40. Now, let me explain that to you now. How do they get plus 20? So again, you start on the left-hand side, like I'm teaching you for beams. Okay, so they are using inward forces which are towards the right. I hope you're writing these things down, students, but the textbook don't explain to you ladders, eh? Forces to the right are plus, forces to the left or arrows to the left are negative. So keep that sign convention in mind. Right. So you can see the first one will be plus 20 minus 40 plus 30 minus P will be equal to 0. It's really grade 5 schoolwork. Okay. I don't expect any student to get this type of thing wrong. Then you are definitely in the wrong faculty. Okay. So that's very easy. And you can see now that's what they've done here. Plus 20 that equate to 0. And the value of P, which is the unknown force, becomes 10. So you must solve for the unknown force 10. Right. Now you are set. Now the question wants you to know what is the total change in length. So you know the rule. The total change in length for this type of series setup is the individual change in length of each member, A, B, B, C, so forth. Okay. How do you calculate the change on length of each individual member? It is calculated by the equation change in length equal to stress length upon E. Stress length upon E. Okay, your textbook may use slightly different notation. As I mentioned to you at the beginning of this course, you use any symbols you want. I'm not interested in symbols. Okay, choose one set and stick with it throughout. Now, if you use the first class that we've done, if you change or if you expand stress, stress is also equal to what? Force upon cross-sectional area. So it is P upon A. Simple school mathematics. My mathematics in this course is school stuff, eh? Please keep that in mind. It's nothing complicated in this course, eh? To my level. All right. So you can use either one of these two. But listen carefully what I'm saying. Sometimes it is quicker to use the stress formula. Sometimes it's quicker to use a load formula, depending on what the question gives you. Most of the time, you'll be using FL upon AE or PL upon AE. Most of the time, you use this one. But some questions give you the stress value. So you can use the stress part. Okay. So you got to apply delta L to AB, delta L to BC, CD, and so forth. Okay. Now, the only problem is now to calculate or determine what the force is at AB. So if your first one is delta L of AB, you have got to start on the left-hand side, as you know. So you got to look at this segment AB now. And hear carefully what I'm saying. The rule says you must put your hand at the border of the section. So you put your hand blocking B and you consider everything to the left-hand side of B. Why? What are you doing? Your aim is to determine what is the resultant force at segment AB. So the rule says put your hand at B. Any force that runs through your hand or is covered by your hand, which is B here, is zero. It vanishes. So that's the rule. I hope you listen carefully. So in other words, the 40 kilonewton disappear. So there's only one force to the left of B, which is 20. Now the question is it positive 20 or minus 20? So put your hand there at B on your screen. Do that. Put your hand at B, your whole palm. And if you look now, so of course that 40 now must vanish. What is that 20 doing to section AB? Listen very carefully. Otherwise, you will be confused if you read your textbooks. That's why attending class is so important, eh? So somebody give me the answer. What will force A do to segment AB? Will it expand it or will it contract it or compress it?
It will compress it.
Thank you so much. I really appreciate it. Sounds like the only voice in the class, eh? I don't know if the other students have a voice and whether they can talk. Okay, but thank you, whoever's answering. I appreciate your interest in your in the lesson. Very good. So keep that in mind. That's it. So what is the force in section AB? The resultant force? It is minus 20 because it is compressing it. Okay, that's it. That's all from my side, guys. My section is finished now. That's all. Right. The same rule now you apply. You can see now what they've done here. So likewise, it's 20. Okay. There's the formula here now. Use the same formula for each segment. So P will be minus 20. What is the length of AB? We're only talking AB. Okay. The length is 0.5 meters. They give you the A value. They give you the diameter. So you can calculate the area. They give you the E value. You put all that in. You end up with the answer of minus 159 times 10 to the minus 6 meters. Finish. Now you apply the same rules to section BC. So if you look at the diagram, what is the resultant force at BC now? The rules do not change. So you put your hand at C. Any force through C vanishes. So the 30 goes. Now you got a tug of war. So you got minus, the 20 is pushing, and you got the plus 40 that is pulling. Remember, you consider summation of forces to the left-hand side of your hand, eh? For the section you are interested in. So what is the answer? The answer is positive 20. Okay, I normally advise students before you do this problem, just write F, AB, F of BC, F of CD, F of DE. Just solve that, write it down, you get 2 to 2 marks for that thing, and then apply the formula for each segment and get your answer. Very, very straightforward, eh? Right, are there any questions on that from anyone? Is everybody 100% clear?
So I just quickly want to make sure forces to the right is negative, right?
No. What you talking about now? You're talking about the first part, the equilibrium part. Do not confuse the students, eh? Otherwise, to unwrap it, it will be an effort. But be specific when you talk. What are you talking about?
When you just said it's the tug of war between the two forces
we're talking
to the left of your hand.
Yes, now we're talking about the change in length part. You got to look at you got to look at the diagram logically. What is pushing, what is compressing. So you can see put your hand on C. B is pulling, it's a tug of war there. A is pushing. So which one is going to win?
Okay, definitely the one pulling.
20 pulling, isn't that so? That's why I call it tug of war. You can see I got years. You can see I got years of teaching experience, eh?
Yeah.
Good, but it's nice. It's nice you ask. Okay, so that's how I teach students remember it easily. Okay, so the answer now for the summation of forces for member BC will be positive 20 kilonewton. All right, so same thing you apply now to you can see to CD, and the next thing you apply to DE. You can see now, so you put in each one, you calculate it separately. After that, you just add up using the formula, total change in length formula, and then you get your answer. I will, listen carefully, I will suggest that students do it like the way I showed you. Do not go into this formula straight. Okay, answer the formula directly with, the question directly with the formula. So I will write this part here first. Okay, total change in length is equal to that, like I'm showing you here. Now I don't know what is delta L of AB. So now you write FL upon AB. Then you can, after that, calculate your forces if you want on one side. Then just put in the values and then calculate them separately if you want. I would suggest you do it like how they've done here. So you get marks for delta L, AB, BC, etc. So you just put it in here. You add them up and you see the bottom line answer. This member will contract, will be compressed by 0.104 millimeter. Okay, very, very easy, eh? Right. There's another type of a question now, which is a class B type of a problem, where you got end loads. Okay, there's the end load. This is a much easier one now. The rule says now that the forces along the complete length or any part or any segment of this member is equal to P. That means P acts at AB, it acts at BC, it acts at CP or PD. I'm going to put a D here. They left out the D. Remember the rules. Wherever there's a force, there must be a letter. Wherever there's a change of cross section, there must be a letter. So there's a mistake here in this book. You're supposed to put a D here. See, the rules don't change. Now, this is an easy problem because you don't have to calculate forces anywhere or resultant forces. Okay, but the rules, I hope you're making notes and you're writing. Eh? The rule says the force along the length of any segment is equal to the external force P, which is applied. All right, so that's the rule here. The change in length formula all remains the same. Okay. So here we are, yeah. Here's the rule. Can you see how they're showing you here? F of AB is F of BC equal to set to CD. Okay. The same rule applies to the total change in length, the same formula. Okay. Now you got two equations. You got that equation and you got that equation. That's why they put in 211, 212. Sometimes they'll ask you questions now where you got to manipulate this equation. You see now in the question, most of the questions are like that. And that is simple, maybe grade 6 or grade 5 mathematics. Simple, simultaneous equations. I don't know what grade they do that nowadays in school. I know when I was in the old standard 7, grade 9, they used to do it. Now, of course, I think it's much earlier. Eh? Right. So very straightforward. Yes, you are, Yana. Now, always remember something, people. In this type of problems, there's 4 ways of solving these things. 4 ways. Okay? Depending if you want to use a stress route, you can see here now. In this way, they're using the stress. So what I said, it was very important. You got your 2 equations here. You use these 2 equations and you solve the unknown problem, what they ask you for. Okay. So you take one equation, you make it a subject of the formula. For example, you can write force in terms of stress. Okay. And then you take that equation and you substitute it in the other one that you haven't used. So you take one equation, you make something the subject of the formula. For example, the stress in member AB is 0.25, stress in BC. For example, there's 4 or 5 ways of solving this problem. Okay, all will be marked right. As long as you get the answer, full mark, no problem from my side. I'm a very nice guy. Okay, so the mathematics is your prerogative. As you practice, you see now how this thing comes. Okay, so you practice, eh? So I'm just teaching you my side. So the trick is take any one of these two equations, okay? Make one the subject of the formula from one equation. For example, if you want to use C, so what write the stress right in terms and say that the stress, you call it a ratio equation. The stress in AB is so many times the stress in BC. Or that you can work the other way about. The stress in BC is so many times the stress in AB. That's why I'm saying there's many permutations to solving this particular type of problem. Okay, so one way they're showing you here in the book now, he's using now the stress in AB. Can you see that? So the stress now in AB works out to be 3,82 stress in BC. They just expanded the formula like I told you to do. One way of solving it, not the only way. Right, then he does for the second one, for member CD and BC, gets another equation there. Just as mathematics now, eh? This is not strength of materials. All right, now you can't. Now we finish the first equation. Remember I said choose one equation, expand it, get a ratio, and then go back to your second equation. So the second equation says the total change in length formula. So now you take your ratio equations and you substitute it in there. Here is it done. You only got one unknown. You only got BC. So you work that out now. The stress in BC is 43,752. Then you substitute this stress into equation 1. You get the stress for CD and so forth. Okay. So I think that is very, very trivial, very easy. Eh? I'm just showing you technique here, people. One type of technique. One type of technique. All right. Then you get another class of problem, not sub-problem now. Yeah, remember we done members in series, students. There's two classes or subclasses of series. One is intermittent loads along the axis. The other one is end loads. You know how to treat them now, right? Now another class of problem under axial deformation is where you have got members in parallel. Now, typical examples when you walk in a supermarket, Pick and Pay and Checkers and all. You look in the aisles there at the beginning of the aisle, they got the sign that is hanging there. Baby section or pets, pet food, coffee and tea. The signboards are suspended by wires or ropes or whatever. So that's what we're talking about here. So you got some type of a load, can be a signboard or something, and it is suspended to the ceiling by types of ropes or wire ropes or whatever. Okay. So they want to know again in this type of setup, what is the change in length? It could be a constant type of application where you're putting up a very high building. Of course, they use wire ropes to carry the concrete slabs. If that thing expands too much, it could hit an adjacent object or something like that. So you calculate, but how much will the rope stretch? Okay, this is a stretching problem. You can get parallel members with compress also. Okay, but that's the thing. So what's happening here, people, is they're just doing a Newton's law, yeah? The downward forces, which is a downward load W or P, whatever you want, must be able to be resisted by ropes 1, 2, and 3. So upward forces equal to downward forces. Very easy, eh? Now the rules in essence are opposite to series. But that's what you must remember here now. That's why you're making notes as I'm teaching, eh? So make it very simple for you guys. So the rules for parallel are generally opposite to that of series members. So you only have to remember one. In the test and exams, if you get parallel, then you just switch the rules around. As you can see here. Now the forces is upward equal to downward. The load W must be equal to the summation of force in each member. It's not equal like the one we just had now. See that? All right, so that's the important rule there. And the second one now, like I said, it must be opposite. It's not adding each one. The change in length of one member will be the same as the change in member 2. Will be the same as member 3. So you can solve for any one. It's also equal to the total change in length. So for a parallel member, someone asks you what is the total change in length. You only need to calculate it for any one member, and that's the same. You don't add anything up here. Eh? What is the formula for total change for change in length? Stress L upon E or FL upon AE. That don't change. Okay, so easier make it for you guys. Huh? You only need to listen. That's all. Right. There's an example here now. They give you same thing. Now the technique of solving it is exactly what I taught you guys. Two equations. You got the two. You got the force equation and you got the change in length equation. Choose one of them. Get a ratio. Force in terms of force or stress in terms of stress. Substitute in the equation you didn't use and solve. Very, very easy. Okay. And you got some pipe is placed inside another pipe. They're giving you the diameters or whatever, and the plates are subjected to a compressive load of 75. So it's like the series setup where you had end loads. Now you got one pipe that is pushed into another pipe. Okay, a lot of examples in practice on this, eh? Right, and the outside loading is 75. They want to know the stress in both materials. Remember, yeah, this is a problem. You got different materials. No problem. Not a train smash. Only the Young's modulus is different. Same thing, eh? It mustn't make you scared. Okay, you just apply the correct Young's modulus where you got AFL upon AE. We're talking for copper, then make sure you put a copper Young's modulus. Okay, and B wants a total change in length. Right, here's how it looks. This is a section through, so you can see. So you got one pipe inside another pipe. Okay, no problem. What Desai says, rule number 1, write down the two governing equations that concern this problem. You can draw a simple sketch if you want, no problem. But the most important thing, you write down the two rules for axial deformation. Very important. Right, there's my two formulas. Yeah, what you're going to say now? Force in steel is equal to force in copper. Equation 1. What's my second one? Change in length of copper is equal to change in length of steel is equal to total change in length. Equation 2. My work is finished. Now it's mathematics. Okay. You can see one way of solving it now. Okay, remember, you're not going to write that down first. They do things upside down, as you know. So you're going to write down your rules. There's equation 1. There's the equation 2 you can write down in terms of stress. So what he's doing is now, there's it here, sorry, equation 2 in terms of force. Force in steel plus force in copper must be equal to 75, not 1 or 3, 75 to the power 3. Yeah, there's a mistake over there. I'll just keep that in mind. 75 kilonewton, 75,000 Newton. Work in newtons, eh? Always. Right, I've done the rules now. So I've written down the two equations. Now choose any one of the two. Mathematics, find the ratio equation, like I taught you, here we are, yeah? Take this ratio equation and substitute it into the one here that you didn't use. Right, but that's all happens now. That's what they've done here, people. And now you end up with stress in copper is equal to 40, stress in steel equal to 80. So practice 1 or 2, you'll see it's very easy, people. It'll bring some good memories of school days for you, eh? The good old school days, eh? Never get them back in your life. I also miss my school days also. Free world, eh? Tell your mom you got homework and you're sitting with your girlfriend, eh? Or boyfriend. You know all the tricks. Eh? Now you're adults now, eh? Got responsibility now, eh? It's part of life, guys. I know you can handle it. I got confidence in you. Okay, but just practice 1 or 2 of these things. You see, it's very easy. Most of it is just simple mathematics. All right. Now, we've done series and we've done parallel. Okay, now don't worry about steel and bolt. We're not going to do that one. I think that's it from my side. If you look now at your problems now, are there any questions before I move on now to your textbook from anybody? Please raise your hand. Feel free to talk. Come here to learn. We don't come here to read textbooks, as you know.
Sir, not quite an answer regarding the work, but one person on the group asked if it's possible to access the slides.
As I mentioned earlier on, slides should be on Brightspace on D2L. It's another textbook, so I cannot just check on Brightspace. The slides are there on Brightspace. Check on Brightspace. The slides are there. I think I've loaded everything on there for you guys. There are a lot of slides there. There's also recordings also. Please don't make me repeat things every lesson. I've told you guys a million times, all that information is on Brightspace. Get out of your laziness and go and look over there. Okay, if it's not there, then you have a lot to complain about. So please check on Brightspace what is there. Everything is there. Okay, the lessons, everything. These slides are all there. So go into the recording. Some of the times you'll see what I've taught you now is on the recording of actually loaded members, or sometimes they place as separate slides also. Okay, you guys are very fortunate. In our days, we never had all these type of things. We had a flimsy black and white textbook with almost no pictures in it, and we had to learn from there. So please, students, look into Brightspace. Everything is there. Right. I think if you now go to page 25 of your book, pay attention. I'll show you what type of problems now you need to concentrate on. You don't have to concentrate on everything. Now, of course, you know the rules that you need to ignore problems that are not in SI units. Right, so you can see now, turn to page 25 of your textbook. They're giving you typical examples. What's nice about this book is they're giving you realistic examples. Can you see there now? Where you got some type of a rod. The first one, M5.1, it has been pulled with 5,000 Newton. See that? Do not let the picture scare you, people. Don't let it scare you. We're only working in 2 dimensions. What I taught you is what I will test you. I will not ask you anything more. Okay, so you can see there now, you got a rod where you're pulling with 5,000 Newton. Okay, I want you to do the problem quickly now. I'm giving you 5 minutes. Okay, do the 5,000 Newton one. Okay, let's rather give you something a little bit more. Okay, hang on. Let's give you something a little bit more. Okay, let's do 5.1. I give you 5 minutes now. So it's 13:40, 13:45. Do not look in the answers. Do not look in the solution. So take the pencil and paper and see if you can do 5.1 for me. I'm giving you 5 minutes to do it. All right. Go for it. I know you can do it. Follow the rules I taught you. This thing will take you about less than a minute to do. Okay, I'm giving you 5 minutes. So please, I would like some answers in 5 minutes time. Do not click on our answers. Right, off you go, guys. I know you can do it. All right, students. Can we have some answers now? Hands up. Who's itching to let me know? Hands up, hands up. Come, guys. Anyone solved it? You should
No, I
get.
did not manage.
Sorry, how much you get?
No. I said I couldn't manage yet.
Why?
Still trying to figuring it out a bit, but we're getting there.
Right, let's help you. A steel rod circular cross section, so it's pi d square. Read carefully the questions, eh? Mokali, you get it? 53.5 millimeter. Unmute your mic, please. Mokali, unmute your mic. Do you get it? No one in my class can solve this one out of 25 people. Okay. Okay, guys. You got a problem here? Telling you the circular cross section. Remember, read carefully. Okay, not all questions are circular. Some of the examples are rectangular blocks. So read carefully. It's circular cross section. 15 meters long. Determine the minimum diameter required if it must transmit a force of 300 without exceeding the stress and must not stretch more than 10 millimeter. The stretching is another word for expansion or change in length. So do not be scared for the words they use. So yeah, it's a question which is upside down. They're giving you the change in length. They're giving you the force or the stress. They're giving you the other information. Now they're asking you what is the diameter. So in other words, they're asking you to calculate the area. From the area, you got pi d square upon 4. Okay? And then you make diameter the subject of the formula. So it's really a mathematics type problem. And it's really, guys, to be honest, it's school stuff. It's school mathematics making subject of the formula here. Very, very easy. So it's just asking you, they're giving you the answer, they're asking you to work backwards. Okay. If you look at your, click on your solution now, you cannot spend much time, guys, in mathematics now. If you look at your solution, you can see over there now, just put your 300. They're using here now, area is equal to load upon stress, making subject of the formula. Okay, you can get an area there. From the area now, you work backwards, you end up with 2250. You're working in millimeter square. From there, that must equal to pi d square upon 4. You make diameter the subject of the formula, and you get 53. Okay, so I think that should be very, very simple. It's just mathematics. I cannot teach mathematics. Yeah, this is really grade 5, grade 6 work in school, making subject of the formula. Right. Go over this example 5.2. Okay, all the examples that are there in your study guide. I can't remember everyone, which are in standard SI units. You make sure you do those problems as practice. Okay. Don't worry about these ones like 5.3, 5.2, you can do 5.3. Of course, you don't worry about those ones. All right. But check what's in your study guide and then follow that. All right. That is my story. That's all it is there. Do you want me now to quickly do thin cylinders? I think it'll take 10 minutes. Or you want me to stop over here and we do thin cylinders tomorrow morning? Some opinions from the students. What do you want to do? Or do you want me to do the memo? I must do the memo quickly also. Or you want me to do the memo and you want to call it a day? Foster?
Yeah, I think let's do the memo and then we call it a day. We've just got a class directly after this.
Okay. All right. So we'll do the memo and then tomorrow I will do thin cylinders with you and maybe torsion, but thin cylinders is a very short section. I will do thin cylinders. So remember that you must prepare for your upcoming test also. So you must start working on tutorials and all these type of things. I think the textbooks are very user friendly. So I hope you guys are working on that. Read the announcements. So let's look at put an up an announcement also on Brightspace. Your scripts are there at the counter in the mechanical engineering reception, in the box. Just take your one nicely and put the back others one nicely back in its place, whenever you're on campus. All right, so I think that is this. Do not worry about too complicated type of problems like this 5.6 and all. I won't ask you that. Okay, 5.7 stuff like that. I will normally don't ask you stuff like that. Normally very simple type of things what we've done in class. Okay, but see the numbering in the study guide and follow that. You'll get something very, very similar to those type of problems indicated to you in the study guide. Okay, there's a lot of movies here also, and you can go through these things also. Do not worry about temperature loading and all. Only concentrate if you listen carefully in class, you'll have no problems. So do not worry about temperature loading and all that. We didn't do all that. I won't ask you all that. That's not for my section. I think Dr. Bianca will do that with you guys. All right, what we've done in class, example, I show you now, the Drosky, the slides, all that in the recording. Okay, I will put up these recordings also. I see they've managed to sort the problem out. So I will put up this class recording also for you guys. All right, so you have everything. Right, let me go to the test. I'm a little bit disappointed. Nobody got 100%. I think one guy got 98 or so. And a lot of students did not get full marks. I'm a bit disappointed. Don't know why. Should have got it right because should have been ready practicing already 1 or 2 problems. Can't tell me you're not ready for the test. I gave you homework weeks ago. If you've done the homework, you'll be ready for the test. It's nothing new to us. You can see the problem for homework and the problem for the test was almost identical. All right. Let me just check here. The test. This is test 2. Let me just look at the test up here. Just a second. Test 2. Check the memo here. Right, that one. Opening up. Let me check. Right, here we are. I'm going to project it now for you guys. Share. Where is it now? Yeah, we are, yeah. All right. Right, can you guys see that? Question 1 memo.
Yes, we can.
Yes, no? All right, thank you. Right, you can see now, normally there's the problem here again to refresh your mind. Okay, very similar to the homework problem. Right, just remember, yeah, you got to a point load here that's acting up, doesn't make any difference, only makes a difference on the sign. So just keep that in mind. Everything else is straightforward, like we've done. Right, of course, now you can start with reactions. Anyone first, you can calculate RB or RE. So you take moments at which section. And then clockwise equal to anti-clockwise. You've got to see which way this beam spins. I think most of you guys got this right, so I'm not spending a lot of time on it. Okay, you can do any one first. Right, so you can see now these are important. You can write down the answers, but I think most of you guys got this right, which is encouraging. 60.4 is RE. Okay, they call it V here because it is, of course, a shear force. But you can write RE. And then the next one is BRB, 69.6. And very important, the check. See, some students are still not doing the check. They're very brave, They got 100% confidence that their two reactions are right. Well, like I say, you can take a horse to the water. You can't force it to drink, I taught you the best that I could, can't force you. Okay, you like me, you want to see me again next semester or next year, you're welcome again to come and see me. Maybe you like me a lot. You want to join me again next year. Right, do the check, extremely important. The next 45 minutes, everything you've done, you'll get 0 marks if one of these reactions are wrong. Very important, Right, so you got the answers. You can take a photo if you want. You can write down the answers so you can practice it. Right, after that now, we are now ready to draw the shear force diagram. Okay, so likewise, as I taught you now on the separate paper on the left-hand side, you can start with, make it a little bit small so you guys we can see the diagram. That one more small here. Right, here we are. All right, so we draw it on a computer, so it's not very clear, but you get the idea. Right, so we start on the left-hand side. The first force is 5, so of course you go 5 down. Remember, you choose your scale here. 1 centimeter is 3 Newton, or 1 centimeter is what? You go 5 down. So of course, from A to B now, you got a UDL. So you already 5 down. 10 times 2 is 20. So you got to go 20 down. So minus 20 plus minus 5 is minus 25. So you go down to that. Right, at here now, you cannot go complete to C. You interrupted. So you got a reaction RB there. So you go up RB and you end up with 44.6 there. Now from B to C, you got a UDL of 25. 25 times 2 is 50. So you're up above the water 44.6. You must go down 50 and you'll end up with minus 5.4 below the water. Yeah, some students go wrong. Yeah, now you got a force that's acting up. You're already 5.4 down. Now you got the force showing you 2 up. So 5.4 plus 2 plus minus 2 is minus 3.4. Simple addition. Come guys, grade 1. We teach you this, plus. A lot of you guys make a mistake over here. You got to follow the rules. You got to work gradually from the left-hand side. Some of you guys forgot this too. You made a mistake over here. Be careful, follow the rules. Work systematically from the left-hand side. At A, between A and B. At B, between B and C. At C. Follow that rules consistently. No need to change or watch out there. So it's minus 3.4. Between C and D, no action. You go straight horizontal. At D, you must go down 3. So I'm already 3.4 down. Plus the minus 3 is minus 6.4. From there to here now, DE, I got a UDL. So it's 3 times 1 is 3. Hang on. Something is not right here. Where am I? Oh, sorry. 25 times 1. The UDL. We already went 3 down. So I'm here. DE is 25 times 1 is 25. I'm already minus 6 down. 6.4 minus 25 will take you minus 31.4. Now you at RE, the reaction up. You go up the reaction, takes you positive 29. Now you got EF, you're interrupted. You cannot go DF, you interrupted. So you have to go EF. So it is 25 times 1 is 25. So positive 29 minus 25 is plus 4. And then you see the magic here at the end. Automatically you go down back to 4. Very easy. Why guys get this wrong, I can't understand. Okay, so that's that one. Then after that, people, you calculate the bending moments at each section. It's a summation of bending moments to the left-hand side. So you can take down this one. So you can take a photo. BMA, of course, is 0. Bending moment at B is very easy, minus 30 kilonewton meter. Bending moment at C, 9.2. I mark very leniently, people. So please don't come and complain with 111 mark. Eh? I really mean it. I mark very, very leniently. Where guys didn't put units and all, I didn't subtract marks. But be careful. In the exams, they will subtract marks if you do not write units. Eh? I was very lenient when I marked. I gave you a chance. Eh? But in exams, you do not put kilonewton meter or you put kilonewton per meter, which a lot of students make a mistake. They will put -1 there. The moderator is very strict. Eh? So I mark very leniently on the test. Eh? Right, so bending moment at D works out 2.4 and bending moment at E works out to be -4. Now you can plot these points directly from the neutral axis. It's not continuation like the shear force. Okay, so here we are here now. Just make it a bit big so I don't want to confuse the... Right, so there's the values now. So you from here, you draw down -30. The next one, you put that force, 9,2. Then you put that one there, that's what you calculated. All the calculated values, you just put dots from the 0 according to scale. Now your problem is you don't know whether these things are curving up or down. So what do we do now? You must take a bending moment halfway between A and B. You got a whole right hand side of your page to do calculation. So you can call this one FG. You call that point G right inside there. So bending moment at G will be 10 times 1 is 10. That's all. Minus 5 times 1. And you see the point will be somewhere here, then you know you concave it like that. Okay, same thing you can do between B and C. You take a bending moment, you see you got a guiding point somewhere here. From there you join there and it goes up there. Okay, now yes, some students make a mistake. Between C and D is nothing. There's a straight line. Some people draw parabola here. You only draw a parabola like here and here underneath UDLs. Maybe those students that never bothered to come to class, eh? We even look at the recordings. Right, so there's nothing there. So you just join the dots from there to there. Now you got UDL, DEEF. So from there now you curve it down. And then from there it's a curve. It's drawn like a straight line here, but it's a computer. It is a parabola here. So from there to there, you draw the parabola upwards. If you don't know whether it curves downwards or upwards, you can read your rules on the shear force, or you can take a bending moment halfway EF. You only look at the forces on the right hand side. If you know what you're doing, you get a point there and then you just curve it up like that. And write down your values, but you can see how you mark. You mark the values over here on the diagram. Okay. So generally you get 3 marks for your reactions. Okay. Then you get 6 marks depending on the diagram. Not all questions are the same in terms of marks, but this is more or less what you can expect in the exams. The mark distribution 6, 5 like that. Right. Now the last question says determine the points of contraflexure and find the maximum shear force. Okay, the maximum shear force, you read it from the diagram, is 44. You can see the highest value. The maximum bending moment is -30. Okay, and then it wants you to find. So you can just read the values off for your points of contraflexure, but I always advise you do the calculation. So where are the points of contraflexure? You got 2 points now. You got this x1 that you want to calculate, and you got this x2 or y2, whatever you call it. Just mathematics now, people. Over there. Okay, you can do any one first. You can see here's the calculation here. You take the bending moment at the point in terms of the x or unknown distance. You equate it to 0. You must end up with a parabolic equation. Xax squared plus bx dash. So this is a very important part. This part here must end up with that equation. Okay, then you use a calculator and you'll end up with 4.699, which is unrealistic, and you get the 2 roots, 2.899, and that's the distance. The first one is 2.899. I take my ruler before I continue. I measure it to around getting around 3, 2.7, 2.5, maybe. All are correct. Then you know 100% my calculation here is correct. You get your 4 marks. Okay, same thing now. You apply exactly to the other point. You get also an equation. Here's the equation here. Important part, equation there, right? End up with that. You remember, you work in your unknown distance. It can be y or it can be whatever, just mathematics. Okay, follow the rules I taught you, work in terms of unknown distance. You simplify, you'll then end up with this quadratic equation. Use a formula or your calculator, and you should end up with 1.749 as your answer. All right, guys, that's it now from my side. Are there any questions from your side before we say
Sir,
goodbye?
can you please go?
Yes.
Sir, can you please go back to the calculations of the share?
The shear calculation.
Yeah, I want to take a quote.
Mean the reactions.
It is before after the reactions.
Here we are. You can take a photo with your phone if you like. I don't mind. You can write down the answer if I were you. You don't learn much by taking photos. That's why the results are always bad. It's all the soft options students have nowadays. Makes you lazy. It makes your brain very lazy. Okay. For our student, I will write down the values or the answers of the two shear forces. And then I will go home tonight and see if I can get the answer. Then you learn something. Just taking photos and looking, you don't learn anything. The brain is dormant. Brain only learns when it becomes active. Okay. All right. Anything else from anybody? I know you say you got another class now. So are there any questions, any
Sir.
tutorial questions that anyone would like to discuss? We still got another 25 minutes. I'm here to help you.
So after the reactions, can you please show the calculations? Thanks, sir.
Okay. Okay, from any other students, are there any queries, problems, with any of the tutorials you want me to do, or you want to call it a day now, as the spokesman said, and we meet up tomorrow morning, 8 o'clock for tin cylinders, and I think we'll do torsion tomorrow. And then next week, we finish up the syllabus. I just want to run through with you, because it is in your study guide, I want to run through with you with springs quickly. It won't be in the test and in exam, so don't worry about that. I just want to run through it with you, because we need to update, or Dr. Bianaka needs to update the study guides to exclude springs in future. Springs is not actually part of your syllabus. Because it's there in the study guide, I'll just very quickly, maybe I can even do it tomorrow also, I think. Yeah, I think let's do it tomorrow. You guys must guide me now, because remember, Dr. Bianaka still got his part. We're in April now, almost in April, and May you'll start writing exams. So let me just scroll down so the guy can take out the other part. You guys must tell me now. So is it all right with you guys that tomorrow we finish up now? I believe you finished your practicals also. So you've handed that in. Thank you very much for that. Is it all right that tomorrow now we finish up with everything? Or you want one more week next week to do tutorials with me? Or must I inform Dr. Bianaka he can continue with next week from you? Please speak to me, guys, so I know what you want to do.
I think
Tutorials.
I'm not gone. Remember, I'm not gone. After Dr. Bianaka finish, or while we are finished with you, or what? Remember, we got one more test to write with me. So when is our test date? I can't remember. Are you writing on the 7th or so? Let me just check my calendar here quickly.
Yeah, it's on the 7th of April, sir.
7th. Okay, so we got basically next week, and then that Monday you want to write. Okay, so what do you want to do? People, you must talk. Sorry, you guys must talk. If one guy talks only and I say yes, the other people don't come later on and say. Eh? I'm giving you opportunity now. You must talk what you want to do. If only one person talk, I'll say yes. Everybody agree with it. Fine, finish and clear. Don't come tomorrow and say but. I don't want to hear stories. Eh? Remember, I'm recording all these things over here. But once I give Dr. Bianaka go ahead, he starts with his stuff. Coming back and all. But I will be available for tutorial questions closer to the exams or whatever. So that I'm not gone. I'm not disappearing from you. You can email me or whatever. We can still communicate. I'm here to help you guys, But I don't want you guys to say, no, Dr. Bianca can continue, and then after that, you say, no, we can continue. So let's hear what the people say. So next week, the following week, where are we now? No, next week, Monday, you are writing your last test with me, right? So we got next week, we still got 2 periods next week to do. Right, let's hear now what you want to say. Okay, please continue, whoever was speaking.
I think we finish up tomorrow.
Tomorrow, okay.
Said.
Yes.
And I think then maybe we can, well, I don't know if we're going to have the test on Monday, on the 7th. I don't know about everyone else. I think I'll be fine, but if they want a tutorial class, I think we can have a tutorial class. I think we should just finish with the test, and then we can start with Dr. Bianca.
Okay, so what you want to do next week, Wednesday? You want to have a last tutorial class?
Yeah, I think so.
But the problem is when you have tutorial class, no students bring up any problems, as you can see.
Oh, yeah.
Okay,
true.
all right, but let's keep it like that. You have a right for that. Are there any other students that differ? Are you guys all happy with the suggestion made? So
Yes.
tomorrow we will wrap up. Okay, thank you for that feedback. So tomorrow we'll wrap up with the syllabus from my side. All right. Then next week, Wednesday, which is next week this time, we will do some revision on all tutorial problems that you have, from any section. Also from your test section, also you're welcome. All right. And then that will be on the 6th, and then on the 7th in the morning, then you must start the test. I don't know what time I put. Remember, you're writing the same venue also, eh? It has to be face-to-face test. And then you write the test on the 7th. And then I think then what you're telling me is then Dr. Bianca can, what I'll do is for that particular test, I will put up the memo up on Brightspace for you guys. I don't want to now disrupt the whole week now just for the revision of the test. I'll put up the memo for you guys. So you have the memo there. Is that fine?
Yes, sir.
Okay. I don't want to disrupt Dr. Bianca's week now. I'm just for 10 minutes memo now. I must obstruct him now. But he like working by the week. So that's what we'll do. So then we finish up completely with me on the 7th. So I will send Dr. Bianca an email that from the 13th or from the 12th, I think when you have practicals, from the week of the 11th, in other words, he's all yours then, eh? All right. Good. Then I'll mark the test after the 7th. I will put up your marks I'll mark leniently, give you guys a break again. It's very easy test. It's what's in your books, basically. What I taught you is nothing difficult. I'm not a guy that's trapping people. And then I will put up the marks, hopefully on the 14th or 15th or 18th, but the 18th. Depends on my schedule. We got about a week to mark. And then I will put up the memo on Brightspace for you for test 3. So you have the memo. Good. All right, guys. I think you must go to your next class now. So thank you very much. I hope you guys have learned something from your test. You learned something in our interactive class today. Thank you very much. Are there any final questions from anyone before we say goodbye? Nothing. All right. So we see each other for final revision on any tutorial problem, any chapter next week, Wednesday. Yeah. And then Thursday, you get ready for your last face-to-face test in the same venue that we've done the last test. Okay, guys. Thank you very much for attending and enjoy the rest of the afternoon. Goodbye.
Thank you, sir. Bye-bye.